Hello students, I'm going to go over with you in this video about the required practical lab to observe how forces affect the extension of a spring. And as an objective, we are going to investigate the relationship between force and extension of a spring. You are expected to measure and record the length accurately, to measure and observe the effect of force on the extension of springs, to collect reliable data, required to plot a force extension graph, and to plot a graph with appropriate X and Y axis scales, and to calculate the gradient. So you need to read every single step and how to set up the lab. I have a video next to show to you how to put all pieces together. And then what you need to do here is you need to complete this data table. The mass is going to be converted to Newton. So we have here 100 grams is the same as 1 Newton force. We are going to be work with force, not with masses. And once you have complete all these, you are going to remove all parts of your that is attached to your lab stand, and then you are going to plot a graph with force on y-axis and extension on x-axis, and you are going to calculate the gradient in 2 units, Newton per centimeters and Newton per meter. So show your work here in this box. One thing that I want to explain to you is a little modification. Instead of using this clip, I'm using a regular paper clip. The rest is absolutely the same. Next, I'm going to show you how to put all those pieces together, how to set up this, how to measure the spring, and how to draw your graph and calculate the gradient. The materials that you need for this lab is a lab stand, a C-clamp, a spring, a paper clip, a meter stick, a ring clamp, a mass hanger, and this is 100 grams already attached to this mass hanger, and those additional 4 mass slots with 100 grams each. To set up this lab, you need to flip this lab stand and attach this lab stand using the C-clamp. Use the C-clamp to make sure this lab stand is stable and is not going to tip over. Please do not tighten the C-clamp too hard, because it's going to make it very difficult to remove after your lab. Then attach this ring clamp at the top of this lab stand. First, measure the length of a unstretched spring in centimeters. So in this case, you have here almost 2 centimeters. Do not include the end rings. Attach this spring around this paper clip and then place in this ring stand. Now use this table from your lab procedure and record here the length of the spring unstretched. In this case, 2 centimeters. Now use this hanging mass and attach to this spring. Measure the length of this stretch. This is your first data. 100 grams of mass, which is equivalent to 1 Newton force, produce a total extension of 4 centimeters. Now add this slotted mass of 100 grams to this hanging mass. Now we have a total of 200 grams. Now measure the new extension. So record this value on your data table. Now add one more mass of 100 grams. And now measure the new extension. This is my third data. Finally, I have included my fourth and fifth mass, and I have recorded the values right here. The extension for when I add 400 grams, this is 16 centimeters, 500 grams, and I have a total extension of 20 centimeters. Once my table is complete, remove all the attachments from the lab stand. Now I'm going to plot the graph force on the y-axis and extension at the x-axis using this data. So these are the scales that I have chosen. For the y, this is my force. I'm using 1, 2, 3 boxes here for each increment of 1 newtons. And for my extension, I haven't plotted the numbers yet, but I'm using this scale 5, 10, 15, 20. Notice that for the x-axis, I have here 1, 2, 3, 4, 5 boxes. So 5, 10, 15, 20 boxes. If from here to here, 20 boxes, and I call 5, so 20 boxes divided by 5, every 4 boxes will be 1 increment. So 1, 2, 3, 4, so that is my 1. 1, 2, 3, 4, this is 2. 1, 2, 3, 4, this is 3. 1, 2, 3, 4, this is 4. 1, 2, 3, 4, and this is 5. Okay, so my first number here is 4, so I'm talking about this one right here. So 4 centimeters is connected to 1 newton. So 4 centimeters connect to 1 newton. So this is my first point. Now I need to find 8. So this is 5. 1, 2, 3, 4, 6. 1, 2, 3, 4, 7. 1, 2, 3, 4, 8. So 8 is connected to 2. Next is 12. 12 is connected to 3. 12 with 3. Next, 16. 15. 1, 2, 3, 4. This is 16. 16 centimeters is connected to 4 newtons. The last one is 20 is connected to 5. So 20 connect to 5. So it's right here. Now I'm going to draw my line of best fit. I'm going to give a name to this graph, and now I'm going to calculate the gradient. Even though in this case I'm selecting 2 points direct from my table, I still want that you go over the triangle process, identify the run section and the rise section, which are the components to find the gradient. So my selected points are 4 newtons and 4 newtons and 2 newtons. So those are my selected points. So it'll be 4 minus 2, and the run would be 16 minus 8. There's a mistake here, this 8. 16 minus 8 and 4 minus 2. Okay, so 4 minus 2 is 2, and 16 minus 8 is 8. So 2 divided by 8 is 0.25. So this is 0.25 Newton per centimeter. Okay, so this is my gradient in Newton per centimeter. So I will be my gradient in Newton per meter. So Newton is the same for -2 is 2, and the centimeter, the length is also the same, 16 minus 8, which is 8 centimeters. But I want to convert this 8 centimeters from this subtraction here, 8 centimeters. I want to convert into meters. So how I do that? You just get 8 divided by 100. So now you have 0.08 meter. So you are going to divide 2, for -2 is 2, 2 divided by 0.08, and we have 25 Newton per meter. Okay, so the final objective of this lab is to find the spring constant of this spring. So when I measure my spring after this experiment, I still have the same value, which is 2 centimeters of the original one. So which means that even though I have forces stretching this spring here, did not deform, and is still on its original shape. So this got to do with this number right here. That's the commercial value that usually we purchase springs. So here is the graph where we close this triangle to identify the run and the rise for the slope. The scales, I started right here, so I hope that was helpful, and how we can complete this lab presenting a graph that you can derive information from it.